So, good morning, dear student. I am Dr. S.P. Chincholkar. So, today we are taking the class on heat transfer. So, heat transfer. So, this name indicates that heat is transferred. So, what is heat? Heat is nothing but the energy which is in transit state. Its unit is joule or kilo unit is kilojoule. Now, the heat transfer subject related with rate of heat transfer, that is heat, which is denoted by Q, that is joule per unit time, that is second, so which is nothing but watt. So the unit of this heat transfer Q dot is Q by T. So unit is joule per second, which is nothing but watt. Now, what is the driving potential for this heat transfer? So when the heat is transferred, so driving potential is temperature difference. So whenever there is the energy flow because of a temperature difference is called as a heat transfer. Now suppose we have to take the difference between the thermodynamics and heat transfer. So thermodynamics it deals with what? It deals with equilibrium states. So it gives the total quantity of heat involved in a process. But it does not predict the heat with respect to time. So this is the subject, heat transfer, which gives the heat with respect to time. So this is heat with respect to time. So which is nothing but rate of heat transfer. So overall what we can call it as, it is nothing but the rate of heat transfer. So that is the basic difference between thermodynamics and heat transfer. Now, what is the need of heat transfer? So suppose there is a pipe. Let us take its length is 1 meter, and through this pipe it is having certain diameter d, through which the water is flowing, whose temperature is TWI. The pipe wall temperature is TW, and we have to find out what is the exit temperature of water. So how it can be found out? It is having certain mass flow rate. Water is flowing with certain mass flow rate in kg per second. So there is a time kg per second. So mass flow rate. So it means the heat transfer is involved. So this can be the solution of this exit water temperature can be obtained by studying the heat transfer subject. Suppose another example we can take to get certain required properties in terms of metallurgy. So how to achieve that property? It is related with the certain specific cooling or heating rate, and therefore it is also needed the heat transfer knowledge is very important to find out this certain process, cooling process, to define this cooling process, to define this heating process. Now this how to find heat. So this heat can be obtained by simple formula m dot c. C is the heat capacity. So it may be, if it is air, so it is having two heat capacities, specific heat at constant pressure, specific heat at constant volume. Otherwise for liquid and gas, liquid and solids, it is having a single specific heat, and del T is the temperature difference. So this is the mass flow rate, kg per second. This is either kilojoule or joule, kilojoule per kg, Kelvin or degree Celsius, and this is the temperature, degree Celsius or maybe Kelvin. So it doesn't makes any difference. Now what are the different modes of heat transfer? So modes of heat transfer. So there are three modes of heat transfer. One is conduction, another is convection, and third is radiation. What is conduction? Suppose I am giving the simple